Yo, 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 Math by the Moon, back again, trying to hit you guys up with domain and range for the transformations you have seen on square root parent functions. Uh, Briefly just said in the previous video that cube root remains negative infinity to infinity for domain and range because they're always going left and right and up and down forever. So there's no exclusions from the domain. For cube root. Now for square root, you cannot do the square root of negatives. So that means that with these shifts that are taking place, we have to find the exact spot in which our domain begins and whether or not our range is actually going up or down, which will be in dilations. So first thing we'll look at then is just some horizontal shifting with how that affects the domain and range. Here we have the parent function, the square root of x. And what we said before is that x, when we have the parent function, I got my table over here. There we go. You can plug in anything from 0 on up. Decimals in between here are legal. So we know that the domain has to be greater than or equal to 0, right? Now, if you look at the graph right here, the graph doesn't go this way at all. Like that's the very beginning point. So I know that the x value is 0 here and it goes to the right. So that's why greater than or equal to 0 is good. The range, now I'm looking at the y values. I know that the lowest point that I have is here and the y value is 0. So I know my range is always greater than or equal to 0. So then I look at the domain and range for the blue one. And this one is shifted 2 units to the right. So my x values actually start at 2 now and go to the right. So greater than or equal to 2. And my range values are still going from 0 on up. So my range are still greater than or equal to 0. Now for my green one, I know I'm shifted 2 units left this time. So my first x is at -2, and then it's phew, that way. So my x's are always greater than or equal to -2. And my y's are always going up again. So my y's are always greater than or equal to the height of this point is 0. So there's that. Now that is just adjusting the horizontal shift, the left shift or the right shift. If we did, a vertical shift as well, if there's nothing underneath the radical, we don't have to worry about the x shift. If you notice, every one of these points, the x value is 0. This is 0, 2, and this is 0, -2. This is 0, 0. So all of our domain values are still greater than or equal to 0 for all of these, right? All of these start at 0 for x. The y values all are going to be a little bit different. So for our parent function, our y values start at 0, right? That's the point for our parent function, 0, 0. So y has to be greater than or equal to 0. For the blue graph, we still know that our x starts at 0. Now our y on the blue graph starts at 2 and goes up. So we want greater than or equal to 2 for our range. For our green graph, our x starts at 0 still. But our y value on the green graph starts at -2 and goes up. Now let's put it all together. So this graph right here is going to shift the parent function. So we know the parent function starts at 0 for x. And we know the parent function starts at 0 for y. For the domain of this one, this point right here is really 3, 5, right? 3, 5 is that point. So what I know is my x value starts at 3 and goes to the right. So I need x's that are greater than or equal to 3. And my y value starts at 5 and goes up. So I know my y values need to be greater than or equal to 5. So the only thing that could really happen would be if a graph is flipped or reflected, right? So let's say we have a graph that looks like, let's say we have a graph that looks like this. Okay, now I have some different things in here I haven't talked to you about yet, like reflections across the y-axis. Matter of fact, let's just do this one right here. Let's do this one. This would be a reflection across the x-axis as opposed to reflection across the y. So what I know is that my horizontal shift is 4 to the right, right? And I know I'm going to shift it 3 up. So instead of starting at 0, 0, I'm going to start at 4, 3. This negative sign right here is going to reflect it downward. It's going to take the y value and multiply it by a -1, so it's going to make it go down. So for the domain of this graph, see if I can get my little doodad up here. All right, for the domain of this graph, what I know is my x's have to be over here. This is 4 for x, right? So, and they're always going to the right. So my x's have to be greater than or equal to 4. And my y's, this is a little tricky. This is at 3 high for y, right? 3 high, right? 1, 2, 3. But the graph doesn't go up. It actually goes down. So for my range, my y's have to be less than or equal to 3. Okay? So depending on how this graph, where it starts, you got to find where it starts. And to find where that graph started, we knew it started at 4 on the right. So instead of 0, 0, it started at 4 and then up 3. This negative sign out in front, which I'm going to do a video about here soon, is going to tell you how the graph, instead of going one way, it arcs the other. It reflects it across the x-axis. So these right here, if you read the graph, the x starts at 4 and goes to the right. I know the graph's going down, but that's about the range. So with this graph, our domain is greater than or equal to 4 for x. All these x's are above 4. And our range, all of our y's, the highest the y is 3. So it goes from 3 on down, so less than or equal to 3. So let's see if I can make up another one here that does maybe even doom. All right, so this graph over here starts at, let's see if I can switch my document camera to the other side now. There we go. The domain of this graph, the x value is -4, and it's going to the left, right? -4, and it's going to the left. So when we write this, we would say something like this, but now we got to figure out what symbol to put in here. Well, the x's are going to the left, so we use less than or equal to for that. The range, the y values, the y value height right here, 1, 2, 3, is 3. But it's also going down, right? When I'm talking range, I'm talking up or down. When I'm talking domain, I'm talking left or right. So this one's going left. So I want to do less than or equal to +3. Whoops, I don't know why I know. carried away there, but so our domain for this graph is from -4 to the left, and our range from this graph is from 3 down. So we use those two to discuss how the domain and the range would happen in this graph. I think that most of them will be similar to this. If you need to look at a graph, don't hesitate to pull it up in Desmos. I know I love Desmos because of how quick it is, but you can actually find the location of the starting point. Just to briefly touch base with you about the cube root, I know I mentioned it at the beginning. Like, let's say I have a cube root of x minus 2 plus 4, something like this. You know, the graph for this, even though it's shifted 2 units right and 4 units up, it's still going left and right forever. And it's still going up and down forever. So it's negative infinity to infinity. Negative infinity to infinity for domain and range. So please let me know if you need any help with this. I will be glad to jump on with you and get you where you need to be. All right, later.